Our objective today is to solve an applied problem using an absolute value inequality. And an applied problem means word problem, story problem. Remind me to tell you how I personally feel about applied problems when we get back to class. I feel very passionately that these are important problems, and I try to include them whenever I can. So sorry. Also, something to keep in mind for the notes is, if I'm going too fast, feel free to rewind or pause. And I know that you're probably thinking, gee, I wish I could fast forward, Mrs. Stern, during normal lessons, but alas, I am not controlled by a remote. So, my personal strategy for reading or working with applied problems is not to read the problem. My first job is to look for the question. How do I know when I'm done with the problem? Usually we find that at the end. So I see we need to write an absolute value inequality. We must solve the inequality, and we must explain the meaning of the answer. So I will be done with the problem when I've finished these three things. So let's try to read, scan, look for important information. I see 11 ounces. And I'm thinking that is going to be something important that I need to remember. And I also see this plus or minus 2 ounces, which I also feel will be important in my problem. Now I'm going to read through the problem to see if I can get some hints as to how to create this absolute value inequality. So as I'm reading, I'm seeing that even on an assembly line, nothing is perfect. And even though it's going to be labeled 11 ounces, that can of soup might not actually have 11 ounces. It might be 0.2 away from the 11, either in the positive or the negative. Right now I'm thinking absolute value might make sense. And we are going to let x represent what are the values that the soup can could possibly be if I actually weighed it at the grocery store. So, since the difference of the actual weight and 11 ounces is plus or minus 0.2 ounces, we can use an absolute value inequality. So here's my absolute value inequality. And I know that that difference or distance is going to be 0.2. The absolute value bars kind of handle that plus or minus for me. Now, can it be more than 2.2? No, it must be less than or equal to 0.2. I will not be able to have a 10-ounce can of soup and label it 11 ounces. Now, distance, as we've talked about, goes with difference. The difference between what the soup can actually has, x, and what it should have, 11, that difference has to be less than or equal to 0.2. That's the inequality. So again, since the difference of the actual weight and the 11-ounce label is plus or minus 0.2, we can use an absolute value. So if we're going to look at my answer, my absolute value inequality is the absolute value of x minus 11 is less than or equal to 0.2. To solve, this is a review from our bell ringer. We will write our two complete sentences. X minus 11 is less than or equal to 0.2. The opposite of x minus 11 is less than or equal to 2. And the word that goes in between is and. To solve the left-hand side, I add 11. So that will be 11.2. I trust you can do these without a calculator. On the right-hand side, I will divide by -1 right away. Don't forget to flip the inequality. I'll solve by adding 11. And x is greater than or equal to 10.8. So, we know that x is greater than or equal to 10.8, and x is less than or equal to 11.2. I'm going to flip this one around. To create a set builder notation. And that is my solve the inequality. You can either write your answer in set builder or in interval notation. The directions did not state which representation was required. My last part of the problem is to explain the meaning of this answer. Well, it means the can's actual weight could be between 10.8 ounces and 11.2 ounces. Now, I know what you're thinking. You're thinking, oh my God, I had to show all of that work for something that I could have done in my head. Why is she making me do this? Well, I've got a couple of reasons. First, we're reviewing absolute value inequalities, so this is a great lesson. Second, this really does reinforce the meaning of absolute value, which I think will ensure more correct answers later on. And lastly, this is a build-up for more difficult problems, so by setting up good work habits now, the problems that we come across later will be a little easier. Now, what I would like for you to do is pause and try the second example on your own. So, even though the problem looks a little different, we still have to write and solve an absolute value inequality and use words to explain the solution. The phrasing of this is a little different. What does it mean to have a tolerance of 0.75? It means that that's how far off you can be, plus or minus. So, when we are setting up the absolute value, it could be off by 0.75. It can't be off by 2 ounces, but by 0.75 ounces, that's okay. And our actual weight can only differ from the 20 ounces by 0.75. Let's solve. We have our two complete sentences separated by the word and. For the left-hand side, all I do is add 20. For the right-hand side, I'll divide both sides by -1 first. Don't forget to change your symbol. And we'll add 20 to both sides again. So in set builder notation, we're looking for values that are bigger than 19.25 and less than or equal to values 20.75. I will rewrite this inequality and then get my final answer mushed together in one inequality. And there's my answer. In words, this means the box could weigh between 9.25 ounces and 20.75 ounces. And that's it. Please make sure that you complete the exit slip using our website. And also, please make sure that you get tonight's assignment from the substitute before you leave. You have the rest of class to complete your assignment.